Hello everyone, good morning. My name is Arthur Wang, the president of Huawei Data Center Network Domain. So today I'm very glad to invite our analyst, Andre from the Forrester.
Nice to meet you. I'm Andre Kines, Principal Analyst. I serve infrastructure and operations, specifically within networking. It's a pleasure to be here. Thank you for inviting me.
Thank you, Andre.
I think one of the things that we're starting to see is maybe a new aspect to networking we've never seen before. But to explain it, let me step back like 15 years ago when we started, or maybe even a little bit longer, when we had server or virtualization of servers. We started forcing more apps to be on the server, so we started increasing the efficiency of the server at the time, which then caused more power to be drawn into data centers, then the rise of IT sustainability. So we started worrying about power, not as much on the networking side, but interesting enough, in the last 2 years with AI, a whole new shift is going on in the networking world, because AI is driving such a large amount of power consumption in the data centers. With the GPUs, we're seeing data centers go from tens of kilowatts to hundreds to thousands of kilowatts. And when we start to think about that, we want all the components in the data center to be efficient. We think about the power usage efficiency of the data center. Power in should be equal to the power being consumed. What we're seeing is that there's efficiencies occurring in there, which affects sustainability, but also the resources around the data center to be able to support the data center itself. And so interesting enough is that the GPUs are running, and we're not maximizing all the power and the efficiency of the performance, because a lot of times the network's being the bottle point of it.
Right.
And so now we're putting a lot more demands on the network. Interesting enough, because of power, not because of other things. The fact is the network has to be a little bit more efficient from moving traffic, go from 18% efficiency capacity of the network.
Yes.
We got to drive it to 70 to 90% and not have links be 1% and 99%. We need to use all the links across there, increase efficiency that way. But ultimately too, we're at an inflection point with nature. Airflow is not good enough to cool things down in data centers, so we're starting to see liquid being used on the compute side. Now we'll start to see that as well as we start to drive the efficiency inside the switches. The reality is probably airflow is not going to be strong enough, and so you're starting to see vendors like yourself, the infrastructure developers out there, really redesigning their switches and their chipsets, optics to be liquid cooled. And so it's interesting enough, we're moving from just packets and whatever to just and network architecture to really networking being part also of the infrastructure design, the physics of the world around us. Very, very different when we think about that networking mindset. Mm-hmm. Is this something that Huawei is seeing as well?
Exactly, Andre. Just like you mentioned, efficiency network are the main cause of the wasted computing power. To resolve the network congestion in intelligent computing, Huawei have developed multiple network load balancing algorithms to boost the AI cluster efficiency. So last year, we had launched the NSLP, which is network stream load balancing, which centrally plan the traffic path across the network and improve the computing efficiency. As MOE, large models had become the mainstream, the communication complexity has increased 100-fold, making flow algorithms inadequate. Leading vendors in the industry are all transition to the per packet algorithms. In this year, we introduced NPLB, network packet load balancing, compatible with the ASIC, NVIDIA, and other GPU vendors, which boosts network throughput to more than 98% and improves the computing performance in AI training and inference by about 10% compared with the industry Ethernet. For a 1,000 GPU cluster, this can save the customers millions of dollars annually. Additionally, the main chip and the optical transceiver of data center network switches account for over 70% of the total power consumption. Optical transceiver liquid cooling has been an industry challenge. It requires the very tight contact between the optical module and the cold plates for better heat dissipation, which keeping the transceiver pluggable. There has been no satisfactory solution in the industry. Our Xinghe series liquid cooling switches use our patent elastic heat dissipation structure and team flexible thermal interface material, which enable 100% liquid cooling for the optical transceiver. The liquid cooling heat dissipation ratio also reached 65%, which is the double compared with the industry average. Which function, make it support 8 switches in the dingle cabinets, also double compared with the industry average. In addition, our unique sealed piping and flow channel design effectively control leakage risk to achieve the 5 nines high reliability. Finally, our unified computing network liquid cooling monitoring platform detects leakage in seconds, supporting unified O&M for the computing, networking, and storage.